Hello everyone. Welcome to another episode of Deep Dive Knowledge. Hello. I've read the summary of your report on evaluating the performance of retrieval augmented generation models, and I'm very intrigued by the topic. I'd like to dive deeper into the methods and metrics used. Can you explain the relationship between retrieval augmented generation and fine-tuning?
Certainly. In the context of retrieval augmented generation, fine-tuning refers to the process of adapting a pre-trained language model to a specific task or domain. Fine-tuning involves updating the parameters of the model by training it on a task-specific dataset. When it comes to the relationship between retrieval augmented generation and fine-tuning, there are two possible approaches. 1. Fine-tuning the embedding model. In this approach, the embedding model, which is responsible for mapping text inputs to vector restudies, is fine-tuned on a retrieval-based task. This fine-tuning aims to improve the effectiveness of the retrieval process by training the embedding model to better capture the semantic relationships between queries and retrieved documents. Once the embedding model is fine-tuned, it is used in the retrieval augmented generation process to generate relevant and coherent responses. 2. Using a pre-trained embedding model. Alternatively, the retrieval augmented generation process can also make use of a pre-trained embedding model without fine-tuning. In this case, the embedding model is already trained on a large corpus of text data, capturing general language patterns and semantics. This pre-trained embedding model is then used in the retrieval augmented generation process to generate responses. Both approaches have their advantages and disadvantages. Fine-tuning the embedding model can potentially improve the relevance and coherence of the generated responses by aligning the embeddings with the specific retrieval task. On the other hand, using a pre-trained embedding model without fine-tuning can offer faster deployment and potentially better generalization to different domains or tasks. In summary, the relationship between retrieval augmented generation and fine-tuning is that fine-tuning can be applied to the embedding model within the retrieval augmented generation process to improve the effectiveness of retrieval, but it is not a mandatory step.
Thank you for explaining the relationship between retrieval augmented generation and fine-tuning. It's interesting to see how fine-tuning can enhance the retrieval process by improving the relevance and coherence of the generated responses. Now, let's discuss the metrics used to evaluate the performance of retrieval augmented generation models. Could you provide some examples of these metrics, particularly for evaluating relevance, novelty, diversity, response length, user engagement, retrieval precision, and coherence?
Certainly. Here are some examples of metrics used to evaluate the performance of retrieval augmented generation models in terms of relevance, novelty, diversity, response length, user engagement, retrieval precision, and coherence. 1. Relevance. Relevance score. Assess how well generated content aligns with the retrieved information. For example, rate relevance on a scale from 1 to 5. Rouge. Recall-oriented understudy for gisting evaluation. Measures the overlap between the generated text and reference summaries. Rouge N measures overlap in n-grams. Words or sequences of words. 2. Novelty. Distinct phrases count. Measure the number of distinct phrases in the generated text to assess its uniqueness. Blue. Bilingual evaluation understudy. Measures the similarity between the generated text and a reference text. Higher blue scores indicate higher novelty. 3. Diversity. Number of unique entities or topics. Calculate the number of unique entities or topics covered in the generated responses to evaluate the diversity. Embedding-based diversity metrics. Utilize embedding models to measure the semantic diversity of the generated responses. 4. Response length. Compare the length of the generated responses with baseline methods to understand the relative effectiveness of retrieval augmented generation. 5. User engagement. Human evaluation. Conduct user studies or surveys to gather human ratings on aspects like informativeness, helpfulness, or user satisfaction with the generated responses. Click-through rate. Center. Measure the percentage of users who click on the generated responses from the retrieval results. 6. Retrieval precision. Precision. Measure the proportion of relevant retrieved results among the total retrieved results. Higher precision indicates better retrieval performance. Recall. Measure the proportion of relevant retrieved results among the total relevant results. Higher recall indicates better retrieval performance. F1 score. A combination of precision and recall that provides a balanced measure of retrieval performance. 7. Coherence. Coherence score. Assess the coherence and smoothness of the generated responses. This can be done through manual evaluation or by using automated coherence models that measure the flow of information in the text. These metrics can provide valuable insights into the performance of retrieval augmented generation models in various aspects such as relevance, novelty, diversity, response length, user engagement, retrieval precision, and coherence. It's important to choose metrics based on your specific evaluation goals and the nature of the task at hand.
Thank you for providing such a comprehensive list of metrics for evaluating the performance of retrieval augmented generation models. It's interesting to see how these metrics cover various aspects such as relevance, novelty, diversity, response length, user engagement, retrieval precision, and coherence. In addition to evaluating the retrieval part of the models, the report also mentions metrics for evaluating the generation part. Could you explain some of these metrics, such as blue, rouge, meteor, cider, perplexity, semantic similarity, and coherence measures?
Certainly. Here are some metrics commonly used to evaluate the generation part of retrieval augmented generation models. 1. Blue. Bilingual evaluation understudy. Blue is a widely used metric that measures the similarity between the generated text and a reference text. It calculates the n-gram overlap between the two texts and gives a score between 0 and 1. A higher blue score indicates a higher similarity. 2. Rouge. Recall-oriented understudy for gisting evaluation. Rouge measures the overlap between the generated text and reference summaries. It calculates the overlap in n-grams, words or sequences of words, and provides various metrics, such as rouge n, rouge l, rouge s, etc., which focus on different aspects of similarity. 3. Meteor. Meteor is another metric that measures the similarity between the generated text and a reference text. It considers both exact word matching and paraphrasing. Meteor takes into account precision, recall, and alignment of words and provides a score between 0 and 1. 4. Cider. Consensus-based image description evaluation. Cider is a metric commonly used for image captioning tasks but can also be adapted for text generation evaluation. It calculates the consensus between multiple reference captions and the generated text, considering both n-gram overlap and semantic similarities. 5. Perplexity. Perplexity is a language model evaluation metric that measures how well a language model predicts a given dataset. It quantifies the uncertainty or the average branching factor of the language model. Lower perplexity indicates better performance. 6. Semantic similarity. Semantic similarity metrics measure the similarity between the generated text and the reference text based on their semantic meaning. These metrics often leverage pre-trained language models or word embeddings to calculate similarity scores. 7. Coherence measures. Coherence measures assess the smooth flow and logical progression of the generated text. They evaluate how well the generated content connects ideas and maintains a coherent narrative. Coherence measures include coherence models and coherence-based evaluation frameworks. It's important to note that different metrics capture different aspects of generation quality, and the choice of metrics depends on the specific goals and requirements of the retrieval augmented generation task. It is often beneficial to use a combination of metrics to get a more comprehensive evaluation.
Thank you for explaining the metrics used to evaluate the generation part of retrieval augmented generation models. It's interesting to see how metrics like blue, rouge, meteor, cider, perplexity, semantic similarity, and coherence measures are utilized to measure different aspects of the generated text, such as similarity, quality, and coherence. Speaking of coherence, the report also mentions the concept of coherence in retrieval augmented generation and its relationship with topic modeling. Could you elaborate on the meaning of coherence in retrieval augmented generation and how it relates to topic modeling?
In retrieval augmented generation, coherence refers to the logical flow and seamless integration between the retrieved information and the generated content. It emphasizes the ability to effectively incorporate relevant information from external sources into the generated text, creating a coherent and cohesive narrative. Coherence in retrieval augmented generation is similar to coherence in topic modeling in that both concepts emphasize maintaining a logical sequence and smooth transitions. However, there is a key difference between the two. In retrieval augmented generation, coherence specifically involves integrating information retrieved from external sources, whereas in topic modeling, coherence often refers to the spatial arrangement or connectivity of elements without a direct emphasis on information integration. To summarize, coherence in retrieval augmented generation means ensuring a logical and seamless integration of retrieved information into the generated content. In topic modeling, coherence generally refers to structural order or connectivity without the explicit focus on information integration.
Thank you for clarifying the concept of coherence in retrieval augmented generation and its relationship with topic modeling. It's interesting to see how coherence in retrieval augmented generation emphasizes the effective integration of retrieved information, while coherence in topic modeling focuses more on structural order and connectivity. Now, let's shift our focus to topic modeling. The report mentions the use of retrieval augmented generation to generate topics for a given content. Could you explain how this process works and what criteria can be used to retrieve relevant information for topic generation?